A very good morning to all of you. Welcome you all to the postgraduate technical sessions of the Faculty of Science of the Annual Research Symposium 2024 of the University of Colombo. This event brings together remarkable researchers, academics, and distinguished guests to celebrate and showcase the groundbreaking research being conducted by our postgraduate community. This year's university theme is Building a Sustainable Future Through Impactful Research. In line with that, the faculty theme is Innovation in Science and Technology for Sustainability. It is my great pleasure to welcome the Vice Chancellor of the University of Colombo, Senior Professor Chair H.D. Karunaratne, the Dean of the Faculty of Science, Professor Uppul Sonnadara, our distinguished keynote speaker, Dr. Sepalika Sudasinghe, the Director General of the National Science Foundation of Sri Lanka, heads of the departments, academic staff members, Senior Assistant Registrar, Senior Assistant Bursa of the Faculty of Science, staff of the library, and the postgraduate students of the Faculty of Science to this special occasion. To officially open today's symposium, we will begin with the traditional lighting of the oil lamp, symbolizing wisdom and enlightenment. Now I would like to cordially invite the distinguished guests to light the traditional oil lamp, which is situated outside this auditorium. I would like to cordially invite the Vice Chancellor of the University of Colombo, Senior Professor Chair H.D. Karunaratne, the Dean of the Faculty of Science, University of Colombo, Professor Uppul Sonnadara, the keynote speaker, Dr. Sepalika Sudasinghe, the heads of the departments, Director of the Postgraduate Studies, Faculty of Science, and Director of the CPGS, Professor Chandima Tilakaratne, Senior Assistant Registrar, Senior Assistant Bursa of the Faculty of Science, co-coordinators of the postgraduate sessions 2024, Dr. Pradeepika Saputantri and Dr. Gayan Dharmaratne, Assistant Librarian, Mr. Madhushan Lankatilaka, and also a presenter from today's technical sessions, to light the traditional oil lamp. Ladies and gentlemen, please rise for the national anthem. Thank you. Now we will be playing a short video about the Faculty of Science. Thank you. Next, I would like to cordially invite the Dean of the Faculty of Science, University of Colombo, Professor Upul Sonnadara, to officially welcome you all to the session.
Thank you, Monica. Good morning, everybody. So, I would like to specially welcome Professor H.D. Karunaratne, Vice Chancellor, University of Colombo. This is the very first time we are inviting Vice Chancellor for this particular gathering, because always the Annual Research Symposium, University 1 is our opening ceremony. We used to conduct technical sessions. Then we have invited Dr. Sepalika Sudasinghe, Director General, National Science Foundation. We had the pleasure of meeting last time when she attended a conference organized by Mathematics. And we have a very special talk from Dr. Laktraj. He's going to talk about machine learning strategies for research enhancement. I'm sure it will be a very fruitful talk for everybody present here. Rather than having a traditional welcome, I thought I will present few slides so that it will be good for all of us to see where we are. So I have few opening remarks here. Now, as you know, yesterday we had the successfully we had the inaugural session for the ARS 2024, and I heard that it went for a long period because so many activities were there. Unlike other faculties, traditionally, we consider that as the opening ceremony, and we have our technical sessions because research is the most important thing for us. So we focus on research papers. But as I think recent years we have been having a short opening ceremony like this one. But I think years to come, maybe we need to start thinking about having a bigger ceremony for the opening one. It's up to the faculty, but this is something we need to think about in the future. So we can celebrate few things faculty has done. We had 11 academics getting Senate awards. Now the bar is high. So earlier the bar was only 2 papers for two index papers for a year for an academic. But this year, science, medicine, technology, and a few other faculties, bar raised to 3. So we had 11, but unfortunately some of the academics, just like science, although they are eligible, they don't apply. So I know 2 from physics, they didn't apply. So I think we should realize this is to showcase our the research ability. So I encourage everybody to apply. Then normally we produce 200 index papers a year, which is a good thing. And I think I can remember NRC when they presented some data in 1999, that was the number Sri Lanka produced, 200 papers. So I think we are producing now that number from this faculty itself. Of course, medical, they produce more than us, but we are actually giving a very good contribution to the ranking of this university. Then from the university, we are producing the highest number of PhD degrees. Last year, I think it went down a little bit, but we produce roughly 20 a year. But I think this number can be increased, but we should be happy that we are producing this many PhDs. I think we are even higher than the Faculty of Graduate Studies often. Then these technical sessions, normally we have 30 technical papers, but this time we have only 24. There may be reasons because so many conferences are coming up. So individual subjects, there are separate conferences. For example, physics, there's one, plant sciences, botany, there's one, various conferences. So our members are submitting for those also. So because of that, maybe we have a lesser number here. This we submit mostly only from postgraduate work. Then I can, because Vice Chancellor also should know that actually I'm very happy to see young academics coming up, and they are actually contributing to research and development quite a bit. And I can name 2 recent past. Dr. Kavisha, she actually brought in a grant from Korea, which is 550 million. I saw that they have misinterpreted and given the credit to UGC chairman in the news. but it was actually Kavisha who brought the grant, and so I think that is something we need to start thinking about. Then the second one, we have, Vice Chancellor might talk about it, we got a land from, I forgot the place, but 12-acre land from down south, and we are now looking at whether we can develop a marine science research center. So that will be not only marine science, but even community medicine and nursing also joining, and hopefully other faculties will join. I think this is a good thing if we can do that, because initially we need some funding to establish the place, but we can bring foreign scientists. I think that's the way when we think about ranking, we should go. So I'm glad that Dr. Kalpani Marasinghe, she's actually already written the proposal for that also. Also, if you look at our defense, with the technology development, we are using technology effectively, but there are drawbacks as well. Now, for example, PhD defense, we totally went to Zoom mode, because 2 foreign examiners or examiners are coming through Zoom because they are living far away. But now faculty is thinking that with the local staff or the people here, we can actually physically meet and the student can physically present, because it doesn't look like a defense when you have it in virtual mode. So I think these are some of the things we need to think about using technology, but certain ones we may want to have a sort of a mixed mode. But definitely technology available to us is helping us quite a bit, because we are looking at even collaborations. You can expand, you can supervise students from faraway places, even from Jaffna. That's not an issue. I myself have a student from Rune, so very often I actually have Zoom discussions. He's graduating this year with his PhD. So these opportunities are opening for us, which is a good thing. Then I will present a few statistics. You can see the number of master's degrees we produce. So this number seems to be increasing now. So this year, last year, postgraduate sessions, we had, I think, 226 students graduating. Not all masters, but I think 173 masters, the rest postgraduate diplomas. But I think what we can look at is whether we can compare with the intake and see actually how many we are producing. So it's, I think efficiency is like 60%. There are opportunities for us to maybe push it further and increase the efficiency. But certainly it looks like it is going up now. Then this is number of PhD. So 2022 seems to be less. But I think there are reasons, because the COVID affected us a lot. We could not bring grants, new grants in. So we had a lot of issues, because almost all our research program depends on grants. So that is affecting us. Then a few things. Now undergraduate intake is 700. Postgraduate intake seems to be around 300. So it looks like a good ratio. But I think when you look at the output, it may be ratio goes down. So efficiency we need to work on. Again, we can be happy that we produce 200 index papers, but again, we have 120 in the staff now. So I'm glad to see that young academics are contributing, but that also I would prefer to have maybe 3 papers per academic roughly to start with. So we have to have strategies to improve the postgraduate programs and the publication output. Definitely we need to discuss that. We need a mechanism to promote and enroll foreign students. That is something we are now working on. So this time Finance Committee, we have submitted a proposal. Hopefully Vice Chancellor can support us. Nuclear science, they have a full foreign student coming in. So we actually start recruiting foreign students for our PhD programs, but the funding has to be either sponsored or through grants. And then Chandima is handling our postgraduate director, handling the Center for Postgraduate Studies. I think we need to enhance the work they are doing. So that is the last point I have. So thank you very much for listening to me. And I wish all the best for all the presenters here. Thank you.
Thank you very much, sir. Now it is my great pleasure to invite the Vice Chancellor of the University of Colombo, Senior Professor Chair H.D. Karunaratne, to speak a few words.
Very good morning to all. I think it is enough few words, no? Okay, I will not discuss much. Senior Professor Upul Sonnadara, Dean of the Faculty of Science, all distinguished academics, heads of the department, and we will actually delighted to meet you today. As you are aware that this time it was a little bit lengthy, yesterday ARS. I think that is because the title is, sustainable future through the impactful research. So sustainability include the environment, economic, business, and social. So we had to select 3 keynote speakers representing 3 dimensions. So that is why it was a little bit lengthy. Anyway, successfully we completed, I think, around 381 abstracts I saw that in the book in this time. And the last year, the University of Colombo has published 3,178 research papers. And the Elsevier, according to publishers, of course, Peradini also published closer amount, but University of Colombo impact factor is higher than all other universities. The reason is that I think our Faculty of Medicine and Science. We know our this year title is Impactful Research. That research will become impactful in 4 dimensions. One is, of course, innovation, as your title today. The innovations are essential within the research. And the second one, of course, is the policy making that should link to the policy making and better off others' lives. And the third, of course, we know the research always should go to the community, how we deal with the community. And, of course, the research must provide outcome for the society. So there are various things, the policy making, networking, that the last one is the networking. So why we need to have this kind of gathering here? Because through the research, we can have better network, particularly when you are organizing this kind of activity, different department, scholars will get together and do it. And yesterday, I saw that the different faculty committee was how they were satisfied, and they said that they had a great opportunity to work with other faculty, academics, when they are doing. And not only that, the research brings network with foreign agencies and other universities. So we need to have that. And I think there is a myth that the research is the only way to go for ranking, but there are many other ways. As Professor Nadra suggested, that number of foreign students, percentage of foreign students in the faculty and university, as well as percentage of the foreign scholars teaching in the faculty and the university also matter for ranking. So there are some other dimensions also for ranking. But anyway, you know that we have about 405 foreign students at the moment in University of Colombo. I think when I became Vice Chancellor, it was only 60. But now we have more than 315 Chinese students for 4 master's degree programs, 3 at the Faculty of Management and Finance, and 5 actually, 1 at the Arts and 1 at the Faculty of Education. So that's how the 315 Chinese students in the University of Colombo. So totally we have 405 foreign students by now. So increasing foreign student is one of the ways your faculty can increase your rank. Rank is not depending only the research. That research which are impactful go into policy making, the community linkages, and probably we know we can have a better network because we are located in the University of Colombo, Sri Lanka, in the center of the Sri Lanka. That's the hub of the Colombo. So therefore, our location we have to capitalize. We have not utilized location up to now. We have to capitalize that also in future. We know that the Faculty of Science have abilities to do that, because the problem, we know the medicine, even medicine, the usually drugs are produced by scientists, not by the doctors, right? So you have many other way. And the sports science going today in dimensions with the medicine, of course, physics and other dimensions. So that I hope that there is a huge potential for the Faculty of Science to contribute, and you are doing very well. Thank you very much for inviting me today. Thank you.
Thank you very much, sir, for your insights and gracing this occasion today. It is now my great privilege to welcome our keynote speaker, Dr. S.R.S.N. Sudasinghe, the Director General of the National Science Foundation of Sri Lanka. Dr. Sepalika Sudasinghe is the Director General, CEO of the National Science Foundation Sri Lanka. She is also a senior consultant to the Sri Lanka Institute of Development Administration, SLIDA. She received her basic degree from the University of Sri Jayawardhanapura, Sri Lanka, a postgraduate diploma in economic development, and a master's degree in economics from the University of Colombo, and her PhD in development administration, specializing public policy management from the National Institute of Development Administration, Thailand. Dr. Sudasinghe is having a sound track record of more than 30 years of professional contribution in the public sector, in academic, teaching, research, and in administrative fields. She has served as the chairperson of several national policy formulation committees, including the National Tourism Policy, the National Traditional Medicine Policy, and the National Food Security Policy. She was also a facilitator for the Sri Lanka National Social Protection Policy. In recognition of her exceptional contributions and achievements in the field of state and government sector, she was awarded the Professional and Career Woman Award in 2018 for Leadership Excellence, organized by the Women in Management in partnership with International Finance Corporation, IFC, a member of the World Bank Group. Let me invite Dr. Sudasinghe to deliver the keynote speech.
So I have to put it to the PowerPoint mode, right? PowerPoint. It works. Okay, right. Good morning, everybody. Distinguished Vice Chancellor, University of Colombo, and also the conference chair, dean, heads of departments, distinguished professors, researchers, ladies and gentlemen. It's for me a great pleasure to be here as the Director General of the National Science Foundation, this remarkable conference, symposium of the University of Colombo today. I think it's important because we believe that researchers, practitioners, industrialists, and technologists, we have a great role to play in changing the lives of the people. So I'm glad that you have lined up several topics, several papers to discuss. I'm sure that you will bring the practical implications by the end of the day. That's the expectation of all of us as the decision makers, practitioners in the country. Let me brief on what really challenges us in the future, coming years, as academics and intellectuals in this country. There are a number of societal challenges, often involving complex human environment systems that are not fully understood by all of us, for which the solutions are immediately, urgently required. So you see the figures that I have taken from the recent report released by the Zurich Insurance Corporation Group and the Marsh McLean on Global Risk Report. So these are the challenges predicted. that shows that how vigilant we have to be. So the most severe risks we may face over the next decade against the backdrop of rapid technological change, economic uncertainty, a warming planet, and conflict. So in this regard, so we, the practitioners, we all have a role to play. So we see that the problems are wicked, and I think that has to be, we have to understand as researchers, investigators, technologists, and also the practitioners in the system. We have to understand that the problems that we see in the society is wicked, interlocked, interconnected. We have to understand that reality. So in that sense, societal challenges continues to grow. Researchers, technologists, industrialists have a significant role to play, particularly in finding social and technological solutions in addressing to the wicked problems and to ensure the well-being of all at all ages. So that's the role of the researchers, technologists, so that the innovations that we bring from science and technology, we should bring responsible solutions, innovations, responsible innovations. That's what the OECD highlights. So then only we can ensure the well-being of the people. That's the challenge. For that, we all have to get together hand in hand, all the faculties, the researchers, that's we have to look into. So in that sense, we all should look into an approach that we can gather all these knowledge, strengths, and our attitudes together, hand in hand, in addressing to those issues. In that sense, that approach has to be vital, strong enough to bring feasible, sustainable solutions. So when we talked about the sustainability and the wicked problems and the sustainable development goals, that we can't forget, because the particularly sustainable development goals highlights the challenges we have. It really talks about the sustainability aspects, the wicked problems that we have in the globe, from the global, internationally to the local levels. So that's the place, that's the idea, and that's the challenge we have, how only the disciplinaries or the subject-wise that we can look into whether we can bring solutions from one discipline or else whether we have to get together, working hand in hand to bring solutions. So in that sense, since these problems are often multifaceted, require holistic approaches that take into consideration the political, socio-economic, science, technology, all these aspects, then only we can bring holistic approaches to these challenges that we have. And interventions in mitigating complex social challenges, those embodied in the Sustainable Development Goals, cannot be generated merely, as I said, based on disciplinary research, but require paradigm shift in the research systems. So that has to be realized, that has to be understood, that we have to be accepted. So what is important in this intervention is that we need to ensure the ability of meeting the challenges in a holistic way. So multidimensional cooperation, multilateral cooperation, and engaging stakeholders at all levels. I think the distinguished Vice Chancellor also highlighted this fact. We should bring the people all together, the policy makers, the researchers, the practitioners, the decision makers, and also, importantly, the grassroots level, the local wisdom that also has to be integrated. Then only we will reach to the system effectively, and our solutions will bring the feasible solutions. So on this topic, actually, very recently, National Science Foundation and also the National Natural Science Foundation, China, we collaboratively organized a forum. It is to bring the research management and to discuss the research management in the era of artificial intelligence. So these are the topics that we discuss. 14 member states of Global Research Council deliberated, discussed, debated on these topics and how working together can create co-creation of knowledge in addressing to global challenges. All the researchers, scientists, sociologists, all technologists, and the research funding agencies, they realize the importance of AI in the research management system. They realize the importance of co-creation of knowledge and inclusion of EDI aspects, equality, diversity, and also the inclusiveness of this work in bringing the solutions to the global problems. So with that in line with that, I invite all the researchers here to join with National Science Foundation to develop your research models, because we have recently introduced a model where we can ensure the industry participation. We call it the lab to market model, where we encourage research work about TRL level 8 and 9, where we can bring the feasible solutions to the society. So I herewith invite all the researchers, professors, scholars here to look into these grant schemes and to work hand in hand, to work for an innovative approach, work for in changing the science and technology with responsible innovations to bring solutions to the prevailing problems in the country. Otherwise, since, as I said, the problems are interlocked and interconnected, we will not be able to address to these problems, because no one can ignore the vital role of the science, technology, and innovation for the sustainable development goals, particularly in providing solutions that society needs to overcome these challenges. So therefore, we always say Santee play and help to understand and navigate the risks and opportunities created by the sustainability transformations. So in that sense, the cutting edge knowledge is vital. So that's why we always say, go beyond boundaries to understand the reality. It's difficult. We have to have unique models if you want to go beyond boundaries. But then only we can, because ensure the quality of life of people. Otherwise, by the end of the day, we have to think of whether the information, the solutions, the recommendations that we provide fit into the real society problem. And we think it's our fault. People think that they are fault. So we have to bridge this gap. So I think it's high time for all of us to look into this. So therefore, I really invite all of you to think of this, and because we have a special program from National Science Foundation in addressing to this. So we have, as you know, National Science Foundation is the place where we ensure strengthen the research ecosystem from basic research to applied research. We have a space for basic research and all. And we have so many, and just check the website of the National Science Foundation, you will find so many opportunities according to your interest. Come and work with us. So at the same time, we believe that that's the theme for today. Innovation in science and technology should bring solutions to the problems. But as I always say, it's responsible innovations. We have to be responsible because it's integral to a country's performance as a key driver for economic development. When we talked about the economic development particularly, it's about the innovations in the science and technology. So therefore, the science faculties, the departments, so you have a vital role to play as intellectuals, integrating your practical knowledge with the practitioners. That gap has to be bridged. So that's my always a concern. And also, it's vital. So when we talked about the addressing to the wicked problems and the sustainability concerns, so it's to what extent our interventions can ensure the sustainability of the solutions and the systems that we bring and that we introduce. So science for developing countries like Sri Lanka in particular, unleashing the innovation potential can facilitate transition to a state of a balanced economy to bring about continuous economic development and to ensure in long run the well-being of the people. So there is a gap in the system, the rich and the poor. So that has to be addressed. This picture I took, and I use it when meet the intellectuals and the researchers and the scientists. So I always highlight there is a responsibility as the taxpayers of this country to look into the demand, needs, voice, and the pulse of the people in addressing to this gap. We know that poverty is multidimensional. It's a multidimensional approach we need. That's why we all should get together in bridging, in addressing to this gap between the rich and the poor, right? So therefore, that's why we always say the problems are wicked and we need to work hand in hand for that. So in that sense, with this message, I'm sure that you will consider this my request. And with this message, let me conclude saying that innovation in science and technology strengthen the management of solutions to current sustainability challenges. It's again responsible innovations. The scientific expertise need to deal with multifaceted and complex sustainability problems that requires innovation, creative thinking, action-oriented and transdisciplinary approaches. Innovation in science and technology strengthen the management of solutions to current sustainability challenges that society faces. So in that sense, importantly, the researchers in the field need to play a critical, vital role in providing impactful scientific research findings in addressing the concerns of the human well-being. With that, I conclude. Let me wish you all the best in your future proceedings. Thank you so much.
Thank you very much for your enlightening keynote address, Madam. We will be presenting a small token of appreciation to our keynote speaker. To present the token of appreciation, let me invite the Vice Chancellor of the University of Colombo, Senior Professor Chair H.D. Karunaratne, and the Dean of the Faculty, Professor Phul Sonnadara, to assist with the distribution of this small token of appreciation. Thank you very much, Madam and sirs. It's a great pleasure to have you all here today with us. As very powerful and indispensable tools in modern research, machine learning and artificial intelligence offers immense potential, and it is now more essential than ever for us to integrate these strategies into our own research practices. Identifying this need, research arm of the IT Service Center proposed a special session on machine learning strategies for research enhancement, which was very generously accepted by Dr. Premantha Lakraj, Dr. Samira Viswakula, and Dr. Dilanga Sirivardhana. This session will explore the transformative impact of machine learning, advancing research methodologies and outcomes. So it's my great pleasure to invite these three machine learning and artificial intelligence experts to conduct this special session on machine learning strategies for research enhancement.
Good morning. So, we are trying to introduce machine learning. So, if you look at this image, I asked a generative AI to generate an cover page for machine learning, and this is what they generated. So, if you look at there, you can see that the machine is learning by reading a book. It seems like the machine is doing its own work, but it is not true. Actually, the developer is the key to everything. So as the researchers, if you are using machine learning, it is better to know the concepts, because developer is the one who is saying what to learn and how to learn. So to tell how to learn, we have to have good knowledge in the concepts. To teach what to learn, we have to have good knowledge in our research field. So, in my talk, I would like to go through the basics of machine learning by assuming that you do not have much knowledge in this field. And then, at the last, I will explain some applications in machine learning in scientific research. These applications are from 4 different fields in science. So we hear about these 3 terms always nowadays: artificial intelligence, machine learning, and deep learning. So, but do we know actually what these 3 are? Now, when we are saying artificial intelligence, assume that we have a robot, and that robot is serving some food. So it may walk, it meets some obstacle, and it tries to avoid that. Now, when it is doing that, probably it is following the developer's instructions. It doesn't mean it learns. It just merely following the developer's instructions. So it will sense some obstacle, and it knows what to do. So if you go to Toyota or some other automobile factory, you can see that these large robot arms. So they are assembling the cars, and they are doing that based on the instructions from their developers. However, in machine learning, it has the machines has the ability to learn. So it can decide things. So it has the artificial intelligence, and also it has ability to learn. So machine learning is a it's a subset of artificial intelligence. And when we are discussing about the deep learning is a subset of machine learning where it uses neural networks, multiple layers of neural networks. So when we go to the basics of machine learning, it is better to know the categories or the types of machine learning. There are mainly 4 categories: supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. So we can choose one of these if we know the theory or some concepts behind it. So choosing the correct technique depends on the data and your research problem. So the default technique is the supervised learning, by assuming that you have data with the target variable. Okay. So if you look at here, this is a kind of a diagram, simple diagram, where we have some shapes, and we have the labels for each shape. For the first one is a rectangle, that index number 1. Index number 2 is also a rectangle. Index number 3 is a circle. Likewise, we have the data, and also we have the target variable. And we train the model based on all this data. So, it means that we are supervising this because we are providing the target variable as well. And then the machine will be trained, and we provide a test set, new data set, to see whether it can perform on a new data set properly. So it must recognize this is a rectangle and this is a circle. The second technique is unsupervised learning. In unsupervised learning, we do not provide the target variable. We are just providing the data. Data means these shapes represents the features of the some data entities. So the machine learning model does not know the target variable, but still it can kind of divide this data into some categories by analyzing the relationships between the data. So this kind of method is called unsupervised learning. There's another method called semi-supervised learning, where we assume that we have a large number of unlabeled data, but we have a number of labeled data. So the machine learning model will pseudo-label these unlabeled data and train the model and see whether it can predict properly, and it can use this labeled data to check whether it can label the unlabeled data properly. So if it is not happening, it will enhance its model until it can label the unlabeled data correctly with high accuracy. The fourth method is the reinforcement learning. Reinforcement learning is where we are providing both data, that means features, and the labels of each feature, and then we send it to the model, and there are two things called environment and agent. So the agent tries to predict for the data entities, predict the target variable for data entities, and environment will provide a reward if the agent can predict properly, correctly. If not, it will give a penalty. In this way, we can train the model to provide us some results with interesting properties. So it is better to know what regression means in machine learning. Regression means we can have numerical target variables and numerical features, so we can find the best fit for the data. You don't need to have only a straight line, but you can have some hyperbola or some other curvature shape. This is regression. The classification means we are classifying our data entities into classes. So this is an example. Over here you can see we classify them into shapes. So most popular examples are like spam detection in emails. So we can classify the emails as spam or not spam. Image recognition, the identifying objects in images. So these are some examples for classification. So this is the workflow, basic workflow of the machine learning. First, we have to collect the data. So data collection is the first thing. And then we have to pre-process them. Because when we collect raw data, there can be some missing values, duplicates. So we have to handle them. Like if there are duplicates, we can just erase them. And if there are missing values, we can replace that missing values with some other value. And also data normalization is important. We are not going through these concepts, but that is also something important in data preprocessing. And then the third step is the feature selection. We can use a correlation analysis or other techniques for finding the features based on the data we have. So when we get the raw data, it may not be the features for our machine learning model. We may process the data and create our own features based on the data we have. And then we feed them to the machine learning model. And we have to, there are so many machine learning techniques, models nowadays. These are some of them. Linear regression, logistic regression, random forest, support vector machine, and neural networks. So we have to choose one of these. As an example, this linear regression, it is a regression model where it finds the best straight line for the data. And logistic regression means it is actually a classification method. So we have to choose the method properly based on the data we have. And then here you can see after choosing the model, we need to train it based on the features we found and the target variables we have. And then we have to evaluate our model, because even though we are training the model, we do not know whether it can work finally, right? So we have to evaluate it using some new data which we didn't use for training purposes. And then we can predict for new data, brand new data, using our machine learning model. If the our model evaluation says the trained model has good accuracy. So we can work with so many data types. So these are some of them: numerical data, categorical data, time series data, text data and image data. So we can meet one or two of these data in our research work. So in this table, you can see these are numerical data, age and height, country and education level. These are categorical data because these are categories. Here you can see time series data where we collect the timestamp versus the some target variable. So here we have time series, sorry, a timestamp like date and time, and here we have the stock price as the target variable. Here temperature. Here we have electricity usage. And another data type is text data. So we can collect data from newspapers or journals or somewhere and use them very popular, most popular one is email, right? So we can classify them as spam or not spam. So we can use the email text for that. So text data and then image data. So we can have different kind of images. So here we have cats and dogs. So we have these images. So we can train our machine learning model to classify them as cats and dogs, cats or dog. So that is about the concepts, basics of the machine learning. Now I'm going to discuss about some applications of machine learning. So this is one of my favorite research work because I followed this a lot. So this is a machine learning, the voltage of electrode materials in metal ion batteries. So Dr. Joshi and the group collected formulas of anodes and cathodes of the batteries, and they have the theoretical voltage for each pair, like a anode and cathode, and they removed the inconsistencies and the repetitions from these data for data preprocessing, and then for each chemical formula we can calculate the average properties, elemental properties like atomic volume, atomic number, atomic weight, covalent radius, oxidization state. Likewise, we can calculate the average and also average deviation. So they calculated these properties as the features. So raw data was this, but the features were this. That's the important thing. So raw data does not mean it is a feature for the machine learning. So we can process and generate the features. And then after feature selection, they fed that to a deep neural network and trained it to predict the average voltage. And this is one of the examples for reinforcement learning. So generative deep learning for target compound design. So these researchers used deep neural network to predict the molecules. So they provided a reward whenever the molecule has some interesting property. Interesting properties means prior to train this, they selected some property, and if it gets the property properly from the generated molecule, then they give a reward. So in this way, they use generative deep learning for targeted compound design. So this is a good example for reinforcement learning. And this is from medical image field. So you can see these researchers use these images of eyes to classify them into several classes. So these images based on stages of diabetic retinopathy. So they use convolutional network and also a fully connected neural network to process these images. So normally CNN, convolutional neural networks, are the deep learning models for image processing, image-based classification. And this is from physics or astronomy. So where we classify, it is about stellar classification. So they collected these images of stars in 2 different ways, and they used these CNN models to generate the features for each image of the same category, and then they kind of connected those features, combined those features, and then used the deep neural network to classify them as shown in this image. These classes are O, B, A, F, G, K, and M. So this is my presentation, and thank you so much.
Okay, thank you for the opportunity. And in this session, I'm going to discuss how to use a tree-based method for data analysis. So basically, I'm going to discuss classical machine learning approaches because they are so well for tabular data. Right, so let's look at the outline of the presentation. So first, I'm going to give you a simple introduction to decision trees, and then 2 variations of decision trees, regression trees and classification trees. After that, I'm going to discuss a simple application using a decision tree, and finally, 2 very famous tree-based methods, bagging and random forest, will be discussed briefly. All right, so then first, why decision trees? So decision trees are so popular among machine learners and data science and statisticians. So here I have listed 5 reasons why these techniques are so popular. The first one is very simple to interpret and very simple to understand. Right? So then usually people think that the way we think is pretty much similar to the structure of a decision tree. The second reason, so we can easily handle nonlinear relationship among a variable. And you know that when we have a multiple linear regression, we model linear relationship. So when we consider natural relationship, they are nonlinear. In a multiple linear regression, we model or we approximate linear relationship, nonlinear relationship linearly. But here, using decision trees and tree-based method, we can easily handle a nonlinear relationship. The third reason, these techniques are so flexible. Okay, the capacities are very high. So then, using these techniques, we can extract subtle variation in your research data. And the third reason is also very important. You know that when we are going to analyze data, we have to spend so much time for data pre-processing. So, but here, if you are using tree-based method, the time we need for pre-processing is at minimum level. So then you don't need to scale variables, and you don't need to think much about outliers and influential observations. And then the last reason is these tree-based methods, especially random forests, work well for structured data and tabular data. So then, when you have research data, I advise you to train random forest first and use it as your baseline model. So then, okay, so now I'm going to give you an introduction to basically explain the main concept of a decision tree using a simple example. Let's assume that someone asks a set of questions from you. Okay, so the first question is, do you want to learn machine learning? And then here, in this case, you have two options to answer this question. You cannot say maybe, okay? You have to say yes or no, two options, right? So then here we have two options, yes or no, and you need to select one of them, right? So then let's assume that the option you select here, okay, I want to learn machine learning. And then based on the answer given to this question, okay, you will get another question, right? The question is, okay, do you have knowledge of statistics? And please keep in our mind, here we get a sequence of question, right? So then, again, we have two options for this one, yes or no. Okay, again, you cannot say maybe, only two options. And let's assume that the answer to this question is yes, right? And then the answers given to first two questions, okay, based on the answers given to first two questions, you will get another question. Okay, do you have knowledge of Python, right? And again, two options, right? So the option is, okay, so in this case, no, right? So then based on the answers given to these questions, we take a decision, right? So then here, okay, decision is, okay, you need to learn Python if you want to learn machine learning, right? So this is the basic structure of a decision tree, right? So then here, okay, so then simply decision tree is a flowchart-like structure, and we have a set of questions, the sequence of questions, and based on the answers to given these questions, or in other words, we have a set of statements, and whether these statements are true or false, we take a final decision, right? So this is the main concept behind decision tree. I'm not going to discuss mathematics behind this, but the idea is this. Right, so then we have two variations of decision trees. Okay, the first one is called classification tree. So in this case, we use credit card balance to classify an individual into credit card default or not. So in this case, my response variable is a categorical. It has two-level binary variable. Since the response variable is categorical, we call this as a classification tree. So in this case, we are using credit card balance to classify individual into two classes, credit card defaulted or not. Right? So then the next variation is a regression tree. So in this case, my response variable is the average monthly salary. It's a numerical variable. We are using working experience in order to predict the monthly salary. So in this case, the response variable is a numerical. We call this decision trees as a regression tree because the response variable is numerical. So then, now let's look at some terminologies we use in decision trees. Okay, so then the top of the decision tree is called a root node. And then these are called internal node. How can we identify them? It's very easy. So then if you take an internal node, it has arrow pointing to it and arrow pointing away from it. Okay, they are internal nodes. And finally, we have these nodes. We call them as leaf nodes or terminal nodes. And they have arrow pointing to them, but no arrow pointing away from them. Right, so then look at this simple classification tree. Okay, this is a little bit complicated, but easy to understand. So in this case, we have a set of independent variables, predictor variables, income, family, family members, and years of education, and whether the individual has a credit card or not. They are independent variables, predictor variables. Using the information of these variables, we are going to classify a customer into a purchaser class or a non-purchaser class. So then we have a particular item, and we are going to predict whether a customer is going to buy that item or not, right? Okay, so then here you can see this decision tree contains a numerical predictor variable. So income is a numerical predictor variable, family members is a numerical predictor variable, years of education is a numerical predictor variable, right? Not only that, so look at this one. It has a credit card, it's a categorical variable. So then the conclusion here, you can use numerical predictors as well as categorical predictors in a decision tree. And then, right, so then the other thing is, look at this one. So then here we have same variable, family members, but the cutoff value, so here the cutoff value is 4, the other one is 2. So we can use same variable in decision tree at a different location with different cutoff, right? So that's another very important thing. Right, so now let's look at how we can use a decision tree to predict the response variable. In other words, how can we classify this customer into one of these two classes, purchaser or non-purchaser. So then here we have 4 variables, income, family members, education, credit card. So then income is 40,000, number of family members is 1, education is 12, number of years, and credit card, just this customer has a credit card. Right, so how can we classify this customer into these two classes, purchaser class or non-purchaser class? Okay, so then first, since the income is 40,000, so then we need to move to this right-hand side. Okay, the root node here, income is greater than 50,000. So if it's greater than 50,000, we need to move to left-hand side, otherwise right-hand side. And then the number of family members is, number of family members greater than or equal to, in this case, here we have only one family member. Again, we need to move to right-hand side. And then has a credit card. Yes, this customer has a credit card. So then we have to move to left-hand side. So then we classify this customer into purchaser class. So that's the way we use a decision tree to make a prediction. All right. So then, So then here I'm going to give you a simple example. Okay. So then here, I'm going to use a decision tree to predict the diabetics. Right. So I obtained this decision tree using a Figma Indian data set. Okay, it's a very famous data set. And then here you can see the root node. And then here the proportion is 0.35, and you can see 100%. And here the 100% means this root node contains all the training observation. So what's the meaning of 0.35? So that's the prevalence of diabetics. So in other words, in the training set, we have 35% of individual with diabetics. So if we have a representative sample here, in my population, we have 35% of individual with diabetics. Okay. So then my variable is glucose. I'm going to split this root node using the variable glucose. And then you might have a problem. Why glucose? And why can't we use other variables? Here we have body mass. Here we have age. And there are many other variables. But first, we split the data, the root node using glucose variable. So then here, to select this variable and to select this cutoff, can you see the cutoff is 144? Why can't we use 200? Why can't we use 150? So this is the solution of optimization problem, right? So then to select the splitting variable and splitting point, we need to solve optimization problem. So in this case, for this data set, okay, it has selected glucose as the variable, and the splitting point is 144, right? So then, if the glucose level is greater than 144, we move to this side, the right-hand side. So now we get this internal node. And then here, this internal node contains nearly 23% of observation, and you can see the proportion 0.74. How can we interpret this? Okay, if you select an individual from the population randomly, if the glucose level of that individual is greater than 144, okay, the probability of that individual has diabetic is 0.74. So, okay, in other words, this individual has a 74% chance to having diabetes. Can we do better? Yes. Okay, so then here, next variable we consider the body mass. So then again, here we solve optimization problem. Okay, this optimization problem has selected this variable as a splitting variable and this point as the splitting point. So then, if the body mass is greater than 30, you are in this leaf node. Look at that. So then here, the percentage is 80%. It means this leaf node contains 80% of observation in my sample, and look at the proportion, it's a 0.881. It's greater than this one. So what's the meaning of this? If you select an individual randomly from the population, if the glucose level is greater than 144 and body mass is greater than 30, so then that individual has 0.81% of chance having diabetes. So that's how we interpret this decision trees. So actually this is a classification tree because here my response variable contain only two categories. Okay, so binary, right? So similarly we can use a regression tree. So then it's very easy to interpret and very easy to understand. And then look at this one. So then after getting the decision tree, you might ask a question, okay, what are the most important variables when we are going to predict the diabetic prevalence. So then here, this graph shows you the most important variable when you are going to predict the diabetes. So can you see the most important variable is glucose, next important variable is body mass, and next age and pressure. So then the message here, you can use decision tree as a variable selection technique. So in your research, you might have 200 variables or 1,000 variables, and you want to select the 100 most important variables. Using this technique, you can select those variables. Right, so, okay, so one more thing. So now when you have a regression, so you have an equation, okay, using the coefficient of equation, you can get an idea regarding the association between the predictor variable and the response. But here, this is an algorithm. We don't have an equation here. So yes, we can get the equation, but it's very complicated. So then, if somebody asks, so what's the relationship between the diabetics and glucose? So we don't have a model equation. So how can we answer that one? So then here we have a solution for that question. It's called a partial dependency graph. Look at this one. So then here, my y-axis represents the probability of having diabetics, x-axis represents the glucose level. So this is called a partial dependency graph. So this is the relationship between the diabetics and the glucose. And you can see it's a nonlinear relationship, and it's a very special. Why? Because we get this relationship after adjusting for other variables. Okay, this is a real relationship. And then next, we have this. So then it's a relationship between diabetics and body mass index, right? Again, this is a partial relationship. So we get this one after adjusting for other variables. And in this one, so here you can see the relationship between diabetics, body mass, and the glucose, okay, 3D graph. So then using partial dependency graph, you can get an idea regarding the association between the response variable and response variable and the predictor variable. Okay, so then, are there any disadvantages of decision trees? Yes, there are some. So then here, the first one, the decision tree can overfit data. It means, as you can remember, decision trees are so flexible, so then sometimes it overfit your training data. What's the meaning of that? The meaning is you can find a decision tree that works well on your training data, but when you're going to apply it on unseen data, it performs poorly. The reason is sometimes the decision tree try to model the noise in the data. So that's the overfitting. The second one is decision trees, the variability of decision trees is very high. If you change the training set a little bit, you will get a drastically different decision tree. And due to these two reasons, sometimes you might not be able to generalize your findings to population. So what's the solution? So we have a simple solution. Okay, the solution is bagging. Okay, bagging, bootstrap aggregating. So then here, instead of taking a decision using a single decision tree, we train several decision trees using the existing sample, and then we take a final decision using all the trained decision trees. Okay, let me explain the idea using a simple picture. Right, so then here, this is my original, okay, give me a second. So this is my original sample, right? And then if you train a decision tree using original sample, sometime it might overfit your data. So then what we do, instead of training a single tree, we take a bootstrap sample from the original sample. Okay, so what's the meaning of bootstrap sample? You take a sample from the original sample with replacement. Okay, then usually the size is the same as the original sample. Let's assume that here size is 1,000, and your bootstrap sample, the size is also 1,000. Then you might think that these two samples are the same. No, they are not same. Why? Because we take the sample with replacement, right? And then, so then what we do, we take 1,000 samples or 2,000 samples or 1 million samples from the original sample with replacement, and using each sample, we train a decision tree, right? So then here, if we take 1,000 samples, then we have 1,000 decision trees, and then we take a final conclusion using 1,000 decision trees. How can we take the decision? It's very simple. So if we are working with a classification problem, we can use a majority voting technique to get the prediction. So what is the meaning of majority voting? Let's assume that we have a binary classification problem, and we train 100 classification trees using this bagging method. So then let's assume that 60 of them classify observation into first class, the remaining 40 classify observation into the second class, the majority is the first class. That's our final prediction. And then let's assume that this is our regression. Here we have a regression problem. So then the response variable is continuous. And then my final prediction is the average of prediction given by individual decision trees. Why do we take average? Because by taking average, we can reduce the variability. Right, so then, okay, so if you have a regression problem, we can take the average. So then, the bagging works well under two conditions. The first one, individual model performs at least marginally better. What's the meaning of that? The meaning is, so let's assume that again, let's take a classification problem again. And then in this case, each tree should perform marginally better. It means if you have a classification problem, the accuracy of each model should be greater than 50%. Okay, 50.5%, good enough, right? So then 51%, good enough, right? We don't need 90%, we don't need 80%, right? So, but after aggregating them, you can get 90% accuracy, 95% accuracy, right? Right, so then that's the first thing. The second one is very important. These individual models should be independent, otherwise this doesn't work well. Why? Because here, each decision tree should look at the different aspect of our data. So if they are correlated, so then the decision tree 1, decision tree 2, 3, 4, they look at the same aspect. So then we cannot improve the accuracy, right? So then the second condition is also very important. But the thing is, usually bagging violates the second condition. Okay, so then here, the trees we get from these bootstrap samples are correlated. Therefore, we cannot improve the accuracy as we expected. There's a solution for this one as well. The solution is random forest. So then here, so this is a random forest. Again, it's pretty similar to the bag model. Okay, so we have the original data set, and we take the random samples. Okay, we take bootstrap sample from the original sample, and then we train individual decision trees using our bootstrap sample. What's the difference? The difference is when we train a decision tree or classification tree or regression tree, we don't use all the features in our original data set. So look at this one. Here, in my original data set, we have 1, 2, 3, 4 features. And in bagging, when you train the decision tree, you use all the features. That's why they are correlated. So then here, as I mentioned, when you select the splitting variable and splitting point, you need to solve the optimization problem and select the splitting variable and splitting point. So when you solve the optimization problem, you don't take all the variable. You take a random sample from original feature set and then use only the selected variable to solve the optimization problem. So strictly speaking, at each split, you need to solve the optimization problem, and when you solve the optimization problem, you select a random sample from the feature set. So sample size, so then here we have in the original data set, we have 4 features. And then, in this case, we randomly select 2 features and solve the optimization problem. The size, the sample size, in this case 2 is a tuning parameter. You need to tune it, right? You need to try with 3, 2, and select the one with high accuracy. Okay, so if you train the decision trees in this way, they are uncorrelated, and due to that, we can get high prediction accuracy. Right, so then this is a comparison. So then here, this is a comparison prediction accuracy-wise. Okay, bagging is better than decision trees. Random forest is better than bagging. So this is prediction accuracy-wise. So then you might ask the question, why do we need decision trees? We can always use random forest. Thing is, in order to get high accuracy, you need to sacrifice one thing. What is that? The interpretability. So then here, if you take the decision tree, it's more interpretable, but accuracy is low. But if you take a random forest, accuracy is high, interpretability is low, right? So that's it. And there's another very important classical machine learning algorithm that is a boosting. Sometimes boosting works better than random forest, but the thing is, parameter tuning process is a little bit complicated. So then if you can tune the parameters correctly, so then boosting works better than random forest. The concept behind boosting is a little bit different from the concept in random forest and bagging, right? So if I have another time, so I can explain the boosting, right? So then, okay, these are the references, and thank you so much listening to my talk.
Okay, good morning. So now you have a good idea about machine learning, and you have seen some applications also, and there are different algorithms for machine learning, supervised learning, unsupervised learning, semi-supervised learning likewise, and you have seen tree-based models which we can use to classify or make predictions for tabular data. So my focus today is how to handle unstructured data, that is when you don't have tabular data. Let's see how we can do that, right? So by the end of today's presentation, I hope you will get an idea about unstructured data, what is transfer learning, what a neural network is, the difference between machine learning and deep learning, and you will get an idea about some Gen AI techniques. I know you are hungry, but give me a couple of minutes, okay? So what is unstructured data? Unstructured data means if you can't put that into a tabular form, it's unstructured. So you have videos, paragraphs, emails, audios, images, social media data. So how can we analyze these, right? So for example, in this data set, I have a column with text. So those are some reviews got for a product, right? So how can we analyze them? So you can't use basic regression or classification because now we have text data, right? Textual data. So there are different techniques that we have to follow when we are dealing with unstructured data. For example, we need a lot of data pre-processing and cleaning in order to use these data into a usable form. If you have text data, usually what we do is we put them into lowercase, and we have to do some stemming and lemmatization to extract the words, right? And we have to remove noise, and if you have long videos, maybe we want to segment them into parts. Of course, we have to extract features from these unstructured data in order to use machine learning algorithms. And we can implement NLP techniques to do this work, right? So for example, if you have a bunch of reviews, I can use some NLP techniques to get a summary for each paragraph or couple of paragraphs. I can get a summary. It will say, okay, it's a good quality product, or it's not likewise, right? Another option is I can get the sentiment out of a paragraph. So maybe they are talking about a good thing about our product or a bad thing or a neutral feedback, like sentiment. Then we can incorporate that variable into our machine learning model rather than, because we can't put a paragraph into the model, right? Okay. Thematic. Sometimes we can extract theme, okay, whether they are talking about experience or is it a complaint or is it again an experience. Likewise, we can get the theme out of this text data. Sometimes we can do some keyword extraction, whether they are talking about a dog food or a peanut. Likewise, the keywords we can extract from text data, right? How can we do this? So of course we can write Python and R codes, right? Or you can use ChatGPT's, Gemini's like LLMs, or I can get the help of ChatGPT's or Gemini's and write my own code, right? Likewise, we can handle this. Then let me introduce a new technique, a new keyword actually, transfer learning and pre-trained models. So what is transfer learning? Transfer learning is we are applying the knowledge that we have on some other domain to a new domain, right? Transferring the knowledge, right? So this is very useful when we don't have much data. Sometimes training these machine learning models takes a lot of time. So also it requires a lot of like high-end computers, right? So in science faculty we have a high HPC cloud, but in some certain cases maybe it's not sufficient. Of course we can't run this on a laptop, so we need to have some higher performing computers, right? So if you don't have, then you can use these type of techniques. So you can use pre-trained, we can use these transfer learning techniques. Then a new term is pre-trained model, previously trained model, right? So let's say you want to model or classify cats and dogs and birds, right? So, but you don't have enough data, or let's say running an algorithm is very expensive and you need some sophisticated hardware. So what we can do is we can borrow a pre-trained model. So you don't need to use the same set of like birds and cats. It can be used to classify images, some margins and circles, rectangles, some shapes. So you can use that knowledge and transfer it to our problem, right? So for example, in this case, in the ImageNet database or the library, they have this object identification algorithm. So from that they can identify dogs, horses, sheep, likewise. So we can directly use this to our medical imaging data set to classify or identify if there's a mass or certain feature. We can identify those things from that previously trained model, right? So these are some applications of Gen AI actually, right? So all these things, the basic building block is a neural network. So some of you have heard of neural network. Some of you are like a bit scared to learn about neural network. But let's see what a neural network is. So most of us are familiar with the simple linear regression setup. When you have two continuous variables, if you want to capture the linear relationship, we use linear regression. So from 8th grade or 10th grade, we know the equation of the straight line, which is y equals mx plus c, right? Then in statistics, we use Greek letters, right? So you can say y equals beta naught plus beta 1x. In order to capture this deviation from the line, we can incorporate an error, right? Epsilon, right? So when you have more and more variables, we can put them after multiplying by a constant. So if you can have like p number of variables, right? So in neural network, what happens is, so this is the biological neuron, right? So we have the cell body, nucleus, and all these things. So basically, it gets an input, it does some work, and it reacts, makes a reaction, or it gives an output, right? So the artificial neuron, what it does is, we have an input, several inputs, then do some computation, and it goes to some transformation, and it outputs something. This is the very basic idea of a artificial neuron, right? So the the very basic neural network, the neuron is the perceptron, right? So what we do is we have a input variable, we multiply it by a weight, we have a bunch of these input variables, and also we have a bias term, then we add them and we put them through some transformation, nonlinear transformation, and we have the output, right? So this is the forward propagation, because it works only from left to right, right? That's the basic idea of artificial neural network, right? So depending on the output type, we can change this nonlinear activation function. If you have a linear form, then you can use the linear. If you have binary classification, only 2 classes, you can use the sigmoid activation function. Likewise, we can carefully select the activation functions. So now you know, in a neural network, we have bunch of inputs and some intermediate layers, hidden layers, and output. We don't know what's happening inside, right? So we don't know, in a regression equation, like an equation, we know what's happening, the weights and all. But typically, we don't know what's happening in a neural network. It's like a black box, right? So probably you will hear about the deep neural networks. So what's the difference between a simple neural network and a deep neural network? In a simple neural network, we have only one hidden layer, right? When you have a bunch of hidden layers or more than 2 hidden layers, we say it's a deep neural network. So the architecture gets complicated. We can tackle down so many scenarios, and also we need a lot of computation power and data also, right? Now what's the difference between machine learning and deep learning, right? Some keywords. So in machine learning, we have an input. We do some feature extraction. A data scientist or an analyst has to do that, feature extraction, and we run through them through algorithms, classification or regression, like Dr. Lakraj explains, tree-based methods can be used, and we can get the output. But in deep learning, algorithm identifies these features, so we don't have to worry about these things, right? Deep learning handles those parts, right? So if you have structured data, life is easy. We can use conventional machine learning, right? But if you have unstructured data, like image of a flower or something, then we can use deep learning algorithms. It will extract the features and it will do the job, right? Okay, so there are so many types of neural networks: feed-forward, convolutional, recurrent neural network, generative adversarial neural networks, etc., etc. So this is a very famous application where we want to identify a handwritten digit, right? Let's say we want to identify this digit. So one option is we can break down into a pixel level. Each pixel has 2 colors. It can be black or white. So those will be the inputs, and some hidden layers are there. Then it will say, okay, what the digit is. Now I'm going to introduce you to a Gen AI or generative AI, right? So generative AI means we are artificially creating some data based on existing data, right? So let me ask a question. So are these images real or fake? Okay, let me simplify this. What about these 2? Which one is real or which one is fake? Or are both of them are real or both of them are fake? Okay, both are fake. Okay, so these are the use of Gen AI, generative AI. Probably you have seen this advertisement by this insurance company where they are using deep fake technologies to create non-existing things, right? So in Gen AI, most of the time we get the use of data augmentation. So I'm going to introduce some terms for you so that you can use them. So data augmentation is the process of artificially generating new data from existing data. So data augmentation. So when you have a very small data set, sometimes it's practical, not that practical to have a large data set, right? So we can use data augmentation techniques to have a bigger data set. Then we can use machine learning algorithms, right? Okay. For example, we have only 2 pictures of butterflies, right? So what we can do is we can use various techniques like we can decolorize, texturize, likewise we can rotate. By doing so, we can do some data augmentation, and then we can use our machine learning algorithms. Another example is this. So we can rotate them, we can change the color. Likewise, by doing so, we can create a bigger data set. So how does data augmentation work? Basically, it has 3 steps. Data exploration step, it will go through the data, existing data, and it will identify the important characteristics, right? And then using some augmentation technique, it will generate some new data, and it will combine the new data with the existing data, right? So what are some data augmentation techniques? In computer vision, we use position augmentation, color augmentation like techniques. In data, when you have an audio data set, right? Maybe we can introduce some noise, maybe we can fast forward the data, change the speed. Likewise, by doing so, we can generate some new data. If you have textual data, we can shuffle the sentences, change the positions, replacing words. Likewise, we can do some data augmentation. Likewise, there are some other augmentation techniques. So what is the role of Gen AI in data augmentation? So basically, there are 3 types of Gen AI algorithms. Okay. First one is generative adversarial networks, or GANs. So you have probably seen in the Dr. Dilanga's slides. So he has shown an application of GAN, right? So GAN has 2 parts, a discriminator and a generator. So generator generates new data. The discriminator tries to identify whether this is synthetic data or the real data. So generator generates data. Discriminator tries to identify whether it's synthetic or real. So over the time, it will the quality of the new synthetic data will get improved. So discriminator will not be able to actually distinguish whether it's real or fake. By doing so, they will generate new data. The other one is variational autoencoders. So there are 2 types, encoders, two parts, encoder and a decoder. So I'm not going to go too much into detail. So they will generate data. The other part is the GPTs, famous GPTs, ChatGPT and all, right? Generative pre-trained transformers. That's the third part, right? So so what are the use cases of data augmentation? When you have limited data in healthcare, so we can use data augmentation. In finance, in order to detect fraud, we can use, because only 1% or less than 1% of data are fraud. So how can we detect fraud, right? So we can augment the data and get the use of it. In manufacturing, if you want to detect the defects in an item, so they can increase the sample size by data augmentation and do it. In retail also, in order to identify products, we can do it. So I found this guideline very useful. How can we use this Gen AI responsibly in our research? So a task force at Cornell University, they have sort of given a guideline. So what they are saying is, in the research process, in all these 4 stages, we can use Gen AI, but we have to be very careful. So in the research conception and execution stage, in research dissemination, research translation, and research funding stages, right? So of course, some of us are using Gen AI to do literature review. There's Gen AI and all other GPTs available, right? And also we can use GPTs to write codes as well, right? Now students are writing very good codes, right? So we can generate data also using GPTs, right? Then in the data dissemination stage, so we can write very nicely using GPTs, right? Downside is we may disseminate some inaccurate data, right? And maybe we will do some plagiarism, right? Intentionally or unintentionally. Right? And there can be some bias because everything is based on the trained data set, right? So some people use peer review, do peer review also using GPTs. It is not good, right? Okay. Then research translation stage is when you are going for a copyright or IP, right? So you have to be very careful when you are using Gen AI, because it can cause so many issues like inventorship, patentability, copyright, authorship, commercialization, data privacy and protection, so many issues. So you have to be very careful, right? And in the research funding, some people use GPTs to write the application, so they will give the guidelines and they will say, my topic is this, write me a proposal, right? So it will do that, but you have to be very careful because PI is responsible for all the write-up, right? So what is your duty when using Gen AI? So duty of verification, verify your data, right? Do verify the accuracy and validity of the Gen AI outputs. Do check for the unintentional plagiarism. Duty of disclosure, right? So it's very good to maintain a documentation. So for which stages did you use this Gen AI, right? What's the percentage you use Gen AI, likewise, right? And duty of discretion. So these are not private. So once you upload something to GPT, they will use your document also to train. And the next person who searches, they will get your idea also. So you have to be very careful, right? So do not share any confidential or sensitive information, right? Okay. So some important prompts we can use, right? I'm thinking about, you can give the topic, but this is not a very good, very novel idea. Can you help me find innovative papers and research from last 10 years that has discussed, right? So you can use Gen AI to speed up your work actually. Also, you can ask GPT, what's the best way to collect data on this topic? What would be the best software? What would be the best techniques? Likewise, then again, go back and forth and check whether you are getting the correct information. Can you identify places in the text? So this is very useful. So you can upload a published paper and you can ask to identify the areas or the sentences or the p-values, the variables, everything. So you can very easily do these things very, you can speed up your work. No need to go to like 35 page document. Within 2 minutes you can do that. So you can like shadow a reviewer also. As a skeptical reviewer who is inclined to reject papers, what potential flaws in my paper do you see? Can I minimize those flaws? But you have to be very careful when you are doing it, because when you once you upload your write-up, it's not yours anymore, right? So thank you so much for having us. Do you have any questions for three of us? Okay, thank you.
I would like to thank all the three speakers for your great presentation, which was very informative and very useful for all of us. And I'm sure that you all are waiting to learn more about applications of machine learning and artificial intelligence in your research. Maybe we can proceed with another session on a later day. So thank you once again for all the three speakers. And now we are about to conclude this inauguration of the faculty sessions of the Annual Research Symposium. As we are about to conclude the inauguration, I would like to invite the program co-coordinator, Dr. Gayan Dharmaratne, to deliver the vote of thanks.
Okay, good morning to you all once again. On behalf of the Organizing Committee for the Faculty of Sciences Annual Research Symposium 2024, it's my honor to deliver this vote of thanks. First, we would like to sincerely thank the Vice Chancellor of the University of Colombo, Senior Professor Chair J. Kararatne, for his overall guidance and support, as this is a part of the university's Annual Research Symposium 2024. Then we would also like to express our heartiest thanks to our keynote speaker, Dr. S.R.S.N. Sudasinghe, the Director General of the National Science Foundation, Sri Lanka. Her insights on innovation in science and technology for sustainability have provided valuable knowledge that will greatly benefit the advancement of research within our faculty. We would also like to thank the Dean of the Faculty of Science, Senior Professor and Chair of Physics, Professor Kusun Nadara, for his invaluable guidance, support, and encouragement to all the faculty members, which has been essential in the successful completion of this event. We are grateful for his role as a member of the advisory committee, where his insights and leadership have greatly contributed to the symposium's success. Now, we would also like to thank all the heads of the departments in the Faculty of Science for their invaluable support and guidance, which enabled their respective staff members to actively participate in the process. The involvement of the faculty members would have not been possible without the backing of the heads of the departments. Now we would like to extend our great gratitude to the postgraduate director of the Faculty of Science, as well as the director of the Center for Postgraduate Studies of Faculty of Science, Professor and Chair of Statistics, Professor Chandima Thirakaratne. Her continuous monitoring of the process, along with her guidance, support, and encouragement, has been vital in ensuring the successful completion of this event. She is also a member of the advisory committee of this event. We would like to extend our heartiest thanks to all the authors for taking their time to prepare the abstracts that will be presented today. Our gratitude also goes to the presenters for their participation on the technical sessions. A special thanks to the postgraduate coordinators in each department for managing the completion of the reviewing process, and to the reviewers, especially those who from outside the faculty, for meeting the set deadlines. Special thanks are due to our esteemed senior faculty members, Professor Tara De Silva, Dr. Romain Jayawardena, Professor Mayuru Vijayasinghe, and Professor Dilrukshi Vijayaratne. We greatly appreciate their valuable contribution as members of the editorial committee. Special thanks are also extended to all the session chairpersons and the evaluators of the presentations for their invaluable contribution in each technical session. We are grateful to all the staff members, including the technical officers, for their assistance in facilitating the technical sessions. Special thanks are also due to resource persons of the session on machine learning strategies for research enhanced by 3 of the faculty members, namely Dr. Dilanjana Sirivardana, Dr. G.P. Lakrajan, Dr. Samira Viswakula, for sharing their wonderful knowledge with us. We'd also like to express our heartiest appreciation to Ms. Kumari Senivaratne, Senior Assistant Registrar of the Faculty of Science, and Ms. Subhashini Premasinghe for their efforts in organizing the necessary arrangements and providing refreshments and lunch. Additionally, we would like to take this opportunity to thank all the staff members of the Dean's Office of the Faculty of Science for their valuable contribution in many ways. We'd also like to express our gratitude to Ms. Sajivani Somaratne, Head of the Science Faculty Library, and all the staff members of the Information and Learning Center for allowing us to use this venue and their invaluable support during the event. Last but not least, a special thank must go to Dr. Sachini Amarasekara, the coordinator of the Faculty of Science Media, and her team for covering the event, as well as Dr. Monica Madhavi for the excellent comparing of the event. That is basically all. Please forgive me if I have missed any names or the order of acknowledgement is not appropriate. Thank you very much.
Thank you very much, Dr. Dharmaratne. With that, we will conclude the proceedings of the inauguration ceremony. Before we move on, I have few announcements to make. The refreshments will now be served at the 4th floor of this building, and you all are invited to join for refreshments first. Since we are out of time a little bit, we will start the postgraduate sessions at 11:15. So all the presenters, session chairpersons, session coordinators, and the evaluators are requested to be at the respective venues sharp at 11:15. And lunch for the presenters will be made available at the session venue, and the lunch for the academic staff will be made available at the Dean's office. So I would like to invite you all to join with refreshments, and immediately after refreshments at 11:15 we are planning to start the postgraduate sessions. So with that, we are going to conclude the proceedings of the inaugural session. Thank you everyone for being here today, and we look forward to a productive and inspiring day of research presentations and discussions. Thank you.